everyone, and welcome to MariaDB Server Cloud MiniFest. Today, I'm going to be talking to you about MariaDB SkySQL, a new database as a service offering directly from MariaDB. But first things first, I want to go ahead and introduce myself. My name is Rob Hedgepeth, and I work on the developer relations team at MariaDB Corporation. And basically what that means is I try to do anything and everything I can to help improve the experience of using MariaDB and MariaDB products. If after this session you have any questions, criticisms, or feedback from myself, please feel free to reach out to me at robh@mariadb.com. You can follow me on Twitter at probablyrealrob, or you can check out some of the code samples that I've gone ahead and uploaded to GitHub at rhedgepeth. Now, let's go ahead and dive into it and talk about MariaDB SkySQL. Well, what is MariaDB SkySQL? For that, I like to start with a very simple example. And of course, you can see that I've got this yellow bucket. We've got some files pointing, or pictured files pointing into this yellow bucket. This is really meant, in the simplest sense, to represent what a database is. It's simply, at the very lowest level, a way that we can be able to persist information or persist data. And of course, if you're attending this MiniFest, you understand that, of course, MariaDB is a database. And of course, it's a lot more complex than that, but we're going to try to build off of this going forward. Now, to understand SkySQL, really, I'm going to put just a very simple image behind it, which is this picture of a cloud. Now, the cloud itself is really here to help us represent a database as a service, right? This ability to abstract away a database, and rather than having to take a product and install it or configure it directly onto some machine that we may have access to, or even a database a machine in the cloud, we can actually be able to utilize a database as a service. So spinning up a service that's available someplace else and be able to use that. And that's what SkySQL is. MariaDB SkySQL is a database as a service provided directly by MariaDB Corporation. Well, why would you use a database as a service? And for some of you, there may be varying reasons for this, but at the highest level, it's an abstraction, right? It helps us eliminate certain things, such as the requirement to provision or allocate resources or a machine, whether that be virtually or a physical machine, in order to be able to contain this database, right? Having to go through the process of setting up that machine or virtualized environment, and then be able to install, right? So download, install MariaDB database, and then be able to configure it to the needs of our solutions or applications, and even getting into the details of how we set up security of not only how you can access the database, but then once you have access to the database, what kind of authorization is in play to allow you to be able to do certain things within the database environment itself. Instead, the dream here is that on the left-hand side, you can kind of abstract this away as any solution, right? There's some code on there, but it's some kind of solution that you, as an engineer, are trying to create, and it, uses a database. In this case, we're using MariaDB. Now, the dream here for a database as a service is that we get this easy button, and then poof, a database exists. Now, of course, we all know that it's not necessarily that simple, because as engineers, and then per the requirements of a lot of our solutions, we need a certain amount of levers and buttons and really some knobs that allow us then to be able to tune or configure the database settings in a way that will actually work for what we're trying to create. Which brings us into MariaDB in the cloud. Now, MariaDB in the cloud, as you may already know, already exists, right? And you likely think of, some likely solutions that you may or may not have already used at this point. And these are what I'm classifying as third-party and really the first generation or first attempt at a database as a service using MariaDB. And it's they're very viable, and it's something that you can still use today. You can use them in RDS, right? So Amazon relational database service. You can use them in Azure databases. And MariaDB is available, right, in these cloud service providers. And they allow you, of course, to use MariaDB Server. You can use them for a variety of different use cases. But all in all, there is self-service design that allow you to spin up and use MariaDB service bits to create a MariaDB service that's available to you in the cloud. Now, where MariaDB SkySQL comes into play is that MariaDB SkySQL, just the highest level, the biggest difference is that it uses the MariaDB Enterprise Server bits. And of course, when you use Enterprise Server bits, then you get a lot of the benefits of enterprise-grade functionality, such as, you know, being able to get that on-premises reliability, enterprise-grade governance, the customizableness, a bunch of words that I'm just making up at this point, but the ability to customize the MariaDB database. And not only that, it's a fully managed service provided by MariaDB Corporation. And with that, it comes with a certain amount of expertise and experience that you get from longtime MariaDBers and people who have used MariaDB in the field with a ton of experience. Now, enough with the marketing slide in here. Let's get into the actual architecture bits of what MariaDB SkySQL is. Now, at the highest level, as we see here at the top, you'll see that I've got this icon for ServiceNow. ServiceNow is a platform as a service that we're using to be able to provide the front end or the user interface that you as an engineer, as a user of MariaDB SkySQL can go into to be able to organize the databases, right? So be able to do everything from inventory management to manage the configuration of the database itself, as well as the workflow that's involved in setting up and maintaining MariaDB. Now, that's a pretty abstracted or pretty high-level example of this. Of course, we'll dive into actually seeing what the portal looks like. But underneath the hood, what's happening here is that MariaDB is provided to you through different cloud providers, such as Google Cloud and AWS currently, and then we're working on Microsoft Azure in the future. But all of the cloud providers utilize a SkySQL control plane. And that control plane then exposes the ability for ServiceNow in the portal, ultimately you as the user, to be able to set up and manage your databases which exist as a SkySQL service instance. Now, we're able to do this using Kubernetes, as I mentioned before. And if you're not familiar with Kubernetes, I highly recommend you go out, do some quick Googling, go check out some of the resources that are available online for Kubernetes. But at the highest level, what this allows us to do is take the Kubernetes API in a very ubiquitous or very standardized way, and then be able to manage the database instances using the different Kubernetes engine services on the different cloud providers in a uniform way. And this allows us then to combine some of the aspects from Kubernetes that take advantage of cloud native capabilities, as well as something called self-healing, and combine that with features like MariaDB MaxScale, which is a very useful database proxy specifically made and tailored for MariaDB database servers. All in all, what you need to know from this slide is that we've provided a very standardized way across the different clouds to allow you to be able to quickly use MariaDB Enterprise as a service. Of course, there's a lot more to it, and if you have more questions or want to get a better understanding from a technical perspective of MariaDB SkySQL, I highly recommend you go out to MariaDB.com and check out the enterprise documentation on MariaDB SkySQL. But what we want to do now is transition to actually taking a look at MariaDB SkySQL. Because rather than go into more slides and dive deeper into the architectural capabilities or some of the service offerings, I want you to go ahead and get a quick look at what MariaDB SkySQL is and how you'd be able to use it if you were actually signing up and taking advantage of it right now. So for that, I want to go ahead and jump over into a new browser window where I've already navigated to mariadb.com/Skyview. And of course, that resolves to products/SkySQL/getting started. And this is all in an effort to have a landing page for MariaDB SkySQL. Now, when you first get to that page, you're going to see that, of course, it's going to provide you with an overview of SkySQL. You've got some videos which allow you to step through the process of how you would set up and then be able to connect to SkySQL. You're going to be able to see some of the features, the customization possibilities for SkySQL, as well as some pricing and some of that stuff. But what we want to look at here is actually the process of jumping into the SkySQL portal, right? We want to take a look at what SkySQL looks like so to give us a better idea of how we'd be able to use it. And for that, we're going to go down to this Try Now button. Now, if it was your first time coming into this page, what you'd be prompted with is, you'd go ahead and create a MariaDB ID, so an account with MariaDB, and then you would go through a couple of steps of registering the fact that you want to sign up with SkySQL. I've already done that, and so I'm just going to click the Try Now, and it's going to take us directly into the SkySQL user interface, which, again, is powered by ServiceNow, a platform as a service. Now, when I click Try Now, it's going to take me directly to cloud.mariadb.com/SkySQL. And this is the portal that I've been talking about where you can go and set up a new MariaDB database service instance, so new databases that you can utilize from your workstation or any other workstation. And when you first get in there, you're actually going to get sent to this screen, which is going to prompt you to launch a service. Now, when you first enter this, you're going to see that you have a couple of options here. From transactional, which is going to allow you to use your standard OLTP instances of MariaDB. You have the ability to use an analytics service, which is going to use something called columnar storage, which uses MariaDB Column Store, which is a particular pluggable storage engine that you can use with MariaDB. You have the ability to combine those, right? So you can use OLTP as well as something called OLAP, right? Where you can combine transactional data with your analytical data in something called hybrid transactional analytical processing, or as we see here, HTAP. And that allows you to combine the best of both worlds there. And then at the bottom, you can see that we have something called distributed SQL. And that has been provided as a scalable or an elastic way to handle massive amounts of information in an extremely elastic and scalable manner using a MariaDB pluggable storage engine called Expand. Now, when you get to this page, you can click on one of these, and what you're going to be prompted with whenever you want to launch a service is you're going to have the ability to change some of the information, right? Some of the things that you expect to be able to change. First and foremost, you have the ability to choose one of the two supported service or cloud service providers in Google Cloud or AWS. So you'll select one of those, and from there you can select a region or regions that you want to have this MariaDB service instance, just depending on, maybe if you have localization requirements or something like that. And from there, you want to select a topology, and this allows you to be able to set up, in this case, from a transactional service, the ability to create a standalone instance of the database service. So maybe you want to create something that you run your development environment or your testing environments, to being able to set up high availability using a primary replica setup or even clustering with Galera. After that, you'll have the ability to set up or allocate resources that exist in the cloud by determining an instance size, where you pick both the CPU or the virtual CPUs that you want to use, as well as the amount of memory. And of course, then you'll get a dollar amount that tell you exactly how much that costs. From there, you can allocate certain storage sizes. You can pick the server version of MariaDB, as well as probably the most important part for being able to actually utilize this service, which is give it a name. From there, you'll just launch a service. Now, I've already launched a couple of services, so let's go ahead and leave this page and take a look. Now, when you come into the services that you've already created, of course, you're going to be presented with information of whether or not the service is up and running. You're going to have the information as far as what you named it, as well as the version that you chose and the types of resources that you've allocated to this service instance. Now, when you click into this service, what's going to be important here is that, as well as, as with the information that you already know about, which is, a certain amount of, data that you've allocated, or, the actual instance sizes that you've set aside for or you've picked out for the particular service. You're also going to get information once it's a spinning instance of things that will help you actually connect to it, such as the address for the fully qualified domain name, as well as the port that you can access the service instance. From there, you'll have to add your IP or a range of IPs, so they'll give access to the machines trying to access MariaDB SkySQL, and then you can show credentials by clicking the Show Credentials button, and it's going to give you the username, the password, as well as some prompts for information to allow you to connect to MariaDB SkySQL. You have the ability, once you've spun up an instance, to be able to customize your configuration using the configuration manager here that I've clicked on the left-hand side. And by default, of course, you're not going to be required to fill in any configuration. That is part of the ease of use or the simplicity that comes with using a database as a service. You're already going to have some default configuration. But in MariaDB SkySQL, you have the ability to get in and change these system variables, right? So if you want to get in and configure your database instance to your workload or to your solutions, you have that capability. Continue on this left-hand side here, you can see that you have the ability to check out the tech preview of something called workload analysis. And what workload analysis allows you to do is it takes into account the information and really the activity on your database, right, to help establish workload trends over a course of time. Now, traditionally, we've probably thought of workloads as being write intensive or read intensive, maybe a combination of the two. But over time, we've realized that workloads are more complex than that. They can change hour to hour, day to day, week to week, right? And they can have different peak times at night or on the weekends. And what workload analysis allows us to do is utilize the power of machine learning to help us optimize exactly how we're using the resources and be able to plan for how we can use and capitalize on those resources, both in a time management and a cost-effective way in the future. So if you'd like to check that out, just go ahead and click away on workload analysis. Now, getting back in our portal, you also have the ability to check out real-time monitoring using the monitoring solution for MariaDB SkySQL. So when you click it, it's going to prompt a new window, it's going to open up a new tab, and then you're going to see your services. Now, once your service is here, you can actually click into your services and you can see different live or real-time monitoring information available within this UI. You can check out exactly the type of SQL commands that you're running. You can check out more information on the database, such as open connections, table locks. You can check more detailed information about the queries, so you can see, what queries are running most often. You can check out your queries per second, your transactions per second. You can even look at the utilization of resources on the machines within SkySQL services, right? So you can check out CPU load or memory issues or memory usage. And of course, you have the ability to check out the MariaDB SkySQL documentation directly from the SkySQL portal. And this just will put you into mariadb.com/product/SkySQL/docs, which will give you a full set of documentation for MariaDB SkySQL. And I highly recommend after this session, if you'd like to know more information, just head directly out to the docs. You can access them completely free. You can check out any of the information. And for those of you like myself that like to dive directly into the code or into the examples, this is a great place to do that. And lastly, one of the benefits of using a fully managed database as a service directly from the source of MariaDB Corporation is that you're going to have expert support, right? So you're going to have support directly at your fingertips to allow you to reach out and ask questions about your SkySQL database service instance directly integrated into the SkySQL portal itself. And that's really it. That is the quick and dirty of MariaDB SkySQL. Let's go ahead and check out these slides here for this last one. For this, I would like to say thank you very much for attending this session. If you would like to learn more about MariaDB SkySQL, please head to mariadb.com Skyview. There you can find out more of the information such as the capabilities and the features as well as pricing. But if you'd like to go ahead and just from a high level, if you're wanting and you're interested in checking out MariaDB Server and getting started with MariaDB, please go and check out the MariaDB Developer Hub, which is at mariadb.com/developers. There you can find a bunch of open source solutions and examples, blog posts, tutorials, webinars, videos that will get you started using MariaDB in a variety of different languages, ecosystems, and platforms so that you can go ahead and check out MariaDB. If after all of this you still have questions, please feel free to email us at developers@mariadb.com. You can follow us at MariaDB on Twitter, or you can go ahead and check out all of our open source examples, including MariaDB Server, on MariaDB-Corporation on GitHub. With that, I would like to say thank you very much for attending this session, and I hope you enjoy the rest of MariaDB Server Cloud MiniFest. Have a great day.
Hi everyone, this is Daniel Ye from Tencent Games. First up, I want to thank MariaDB Corporation for reaching out and inviting us to make this presentation. Today, my topic is to introduce our TenDB cluster, a distributed database solution based on MariaDB and Spider. First, I want to briefly introduce our team and our company. I'm a database engineer at Tencent Games Cross DBA team. Our team is responsible for providing database services for most of Tencent Games. We have more than 10 years experience of using and developing MySQL and more than 5 years of MariaDB. Over the years, we have been actively contributing and advocating both MySQL and MariaDB. As for Tencent Games, we're the world's largest game company by revenue. And in 2020, our annual revenues are up to 24 billion US dollars. And these are the content of my presentation today. First, I'll be talking about what TenDB cluster actually is. And next up is some statistics about TenDB cluster. Then I'll do a simple demonstration of deploying and using TenDB cluster with Docker Compose to give a better sense of what it does. Then I'll introduce how we're bringing TenDB cluster to cloud, which is by bringing it on Kubernetes. Finally, there are some contact info of our team. So, what's TenDB cluster? Before I introduce TenDB cluster to you, I want to first introduce Spider in MariaDB, because it's the basis of our TenDB cluster's architecture. Spider is a database sharding and proxying solution. It's built into MariaDB as a pluggable storage engine, so it's also called Spider Storage Engine. When we create a Spider table, Spider will create table links to one or multiple remote servers, also known as backend data nodes. The records in the Spider table are not actually stored in the Spider instance. Instead, they're stored in the remote servers. As you can see from the picture to the right, just one Spider instance in the middle and two remote servers at the bottom. A DML or DDL operation sent to Spider will get distributed to the backend data nodes for actual execution. As you can see, Spider's presence is intrinsically more like a proxy server. And when you query records on a Spider table, it makes you feel like you're handling a single table on a single instance. But in reality, the records could come from multiple remote servers. So Spider offers built-in database sharding and proxying features with a very intuitive interface. It's proved to be a great solution to load balancing under huge data loads and heavy write traffic. And this is basically the reason why we chose Spider as the core of our TenDB cluster's architecture. Now I'm going to talk about what TenDB cluster actually is and what it can do. As you can see in the picture, a typical TenDB cluster is made up of 3 parts. At the center is T-Spider, which is in charge of database sharding and query proxying. T-Spider is our fork of Spider Storage Engine in MariaDB 10.3.7. Over the years, we've added tons of features and performance optimizations to T-Spider. As I said before, Spider is actually a storage engine inside MariaDB. So it naturally supports MySQL or MariaDB protocols and can process basically any request using MySQL's standard APIs. When T-Spider receives a query from the application or a user, it will first look into its routing tables and then rewrite and distribute the query to the underlying backend data nodes. In our case, these are those TenDB instances at the bottom. And after all the data nodes finish executing the query, T-Spider will collect and pack the results, and then send it back to the application or the user. Since T-Spider itself doesn't store actual data records, it only stores database and table structure, so it's almost stateless. This allows us to horizontally scale T-Spider with very little trouble. And at the bottom is TenDB. This is where the data are actually stored. Note that in TenDB cluster, you don't necessarily have to choose TenDB as your data nodes. It's okay for you to use MariaDB, MySQL, or even Percona server, as long as your chosen database understands structured query language. Yet we strongly recommend you to try TenDB out. What's cool about TenDB is that we've developed a lot of cool features. Take the instant add column, for example. On 10db, you're able to add a column to a large table almost instantly without needing to wait for several hours for the change to take effect. This feature is merged into MySQL and MariaDB in the latest versions. Other than this, we also have features like blob compression, binlock compression, which can be really helpful for production and database management. Lastly, to the right is TDB control, whose job is to make sure the cluster works correctly. One crucial part of its job is to configure routing within the cluster. That is to maintain the links between tSpider and the data nodes. Another important task it does is monitor the cluster status, making sure things like privileges, routing, table structure in the cluster are healthy, and report errors if not. Now you may be wondering, why should you use it? Actually, there are lots of cool benefits that come with our 10db cluster's architecture. The first one is about convenience. 10db cluster offers great transparency in design. When using 10db cluster, you don't need to write a complex query specifying all the locations of the shards to create a table. Instead, you can just do it like you're doing it on a single instance. The sharding is automatically done by the cluster and leaves you no worries. Additionally, for sharding strategies, you can choose from various options like hash, range, or list. You're also allowed to design your own strategy. And what's also awesome about 10db cluster is that it supports dynamic scaling. It means the cluster's running status does not necessarily get interrupted while you perform scaling. For a tSpider, depending on your scaling up or down, all you need to do is add or remove tSpider nodes, both in your application's name server and the cluster's routing table. For 10db, we support vertical scaling. In this case, you need to do a hot backup and restore the instances on your new machine, then modify and flush the cluster routing. As for high availability, it's also easy and simple for 10db cluster to recover from breaks. For 10db, if your deployment is a master-slave pair, you only need to redirect the link from tSpider to the healthy slave node in the cluster routing. In the case of GR, that is group replication, broken nodes will be automatically kicked out. This is also the case for TDB control, since TDB control is usually deployed with GR. For tSpider, simply cut access to broken nodes by removing them from name server and the cluster routing is enough. For now, a heartbeat detect mechanism is integrated into TDB control to find and report broken nodes. In all future releases, TDB control can be able to fix them and maintain cluster routing itself without needs for extra tools. Now, here are some statistics about 10db cluster. Here at Tencent Games, our 10db cluster solution is widely applied to various applications, mostly games. At present, there are more than 100 games using our solution, and more than 1,000 clusters are deployed. Within those clusters, there are thousands of tSpider instances, tens of thousands of 10db instances, and up to 2 petabytes of data are stored. All these statistics are solid proof for the usability and reliability of our solution, and also the motivation for us to keep improving and innovating. Outside Tencent, there are also lots of companies actively adopting our solution. They mostly are companies that Tencent has invested in, covering fields like gaming, finance, and insurance. We sincerely welcome every individual or company to join our community and use our product. This will be a great honor for us and also a great opportunity for us to improve and make it better. You can see our official site and GitHub repo to the bottom left. To make you better understand what 10db cluster actually is and what it does, we additionally added support for deploying a 10db cluster with Docker Compose in order to allow you to get a quick hands-on. So now I'm going to demonstrate how to deploy our 10db cluster with Docker Compose, and I'll also perform some simple operations on a cluster. Now, the first thing you want to do is go to our 10db cluster's GitHub main repository. And the address is github.com/tencent/10db cluster-tSpider. Here you can see all the source code of our tSpider. And if you look into the README, there's a quick start section. And if you click on the link, it leads you to our official website. And here's a tutorial guiding you how to quickly deploy 10B cluster with Docker Compose. So my demonstration here is basically following this tutorial. And if you have any questions or if you don't understand any step that I make in the following demo, you can just go to our official website, 10dbcluster.com, and check out this tutorial right here for detailed info. Also, please note that deploying a 10db cluster with Docker Compose is just for demonstration purposes. And since it's only deploying 10db cluster on a single machine, so there's no actual practical use for production. So please don't use it for production. Okay, the next thing you want to do is make sure Docker and Docker Compose are properly installed on your machine. Here on my test environment, I have a Docker version of 18.09.7, and for my Docker Compose, it's 1.28.6. All right. Next, I'm going to clone our 10db cluster Docker Compose repository. You can see the address here. So I'll just save my time from typing it, and now I'm going to clone it. And it should be done in a few seconds. Okay, here we go. Now you go to this repository. Okay, well, in this directory, let's zoom in a little bit. You can see several files. And if you look into the config directory, you can see 3 configuration files for 10db, tspider, and td control. And among these files, the most important one is the Docker Compose file. Let's take a look at it. So this YAM file contains all the configuration for our cluster. And you can see it contains a lot of specs and also specs for each of our cluster's nodes. And you can see the first one is the spec for our first 10db instance. And also you can see the second instance, the third one, and also the fourth one. So there are 4 10db instances in our cluster. And there are also specs for our tspider. There are 2 tspider nodes. And the last one is the TDB control. So among these specs, you can see some important ones. For example, the image. This is the image path for our 10db instance. You can obtain the image file from hub.docker.com. And this is our container name. So within our Docker's network, you can actually access these nodes with this container name as host, and also the port forwarding. So as you see, we can access this 10db instance with the port 20,000 on our local machine. Also here, you can see there are some file mappings that is done under this volumes tag. First, you can see it maps the 10db configuration file that I showed you before into the Docker container. So when the 10db instance is starting, it can read the configuration file and then use to configure this instance. And also it's the data directory. And when we are accessing the cluster, we're using a user that's called 10db cluster. And the corresponding password is 10db cluster pass. Since it's a very simple demonstration, so we are storing them with plain text here. And that's it for this YAM file. And now it's time to start our cluster. And it's very simple to do that. All you have to do is type in Docker Compose up. And then what it does is Docker Compose will read the configuration file that I introduced before, and then it will pull the images, create the containers, and start the instances and configure the routing within the cluster. And now all you have to do is wait for the configuration to be finished. You can check the container status by using the Docker PS command. And when all the containers are healthy, like this, then that basically means the cluster is ready to go. And now what you can do is you can log into the Spider instance, which is at port 25,000. And then you can check the server table. Like this. And then you can see this is the routing within the cluster. And as you can see, it contains the unique identifier for each node in the cluster, and also the host and the port. So when Spider receives a query, it will look up this table to check the route to its backend data nodes, and then distribute the query. And now I'm going to perform some simple operations on a cluster. First up, I want to create a simple database. That's called my test. And now use it and create a simple table. My table. And it has a int primary key in a text field. And let's see the table's definition. As you can see here, I didn't specify any partition info in my create table query, and still LT-Spider does the partition itself. And the number of partitions actually depends on the number of backend data nodes in your cluster. And in my case, there are 4 10B instances at the bottom. So LT-Spider creates 4 partitions tables on each of the 10B instances. And now I'm going to insert a record into this table. And then a few more. And then I'll do a select to see the 4 records. And you can see all of the 4 records. And all these operations make very little difference between operating on a single instance. But in fact, none of these records are stored on this T-Spider instance. Instead, they're stored separately on those backend data nodes. And we can verify that by logging into one of our 10DB instances and check it out. And now I'm going to log into one of the 10DB instances that's at port 20,000. And let's see the databases. You can see the my test with the _0. That means this is the first shard among those 10B instances. And let's see the content of it. And then we do a select. As you can see, there's only one record on this shard, and that apparently means that the other 3 records are on the other 10B instances. And now we go back to our T-Spider instance. And now we can perform some other DML operations. For example, I can delete a record where the key is 4. And I can update the record, setting the second field to hello world, where the key is 3. Then we do a select. As you can see, these operations are successfully executed on our backend data nodes. Otherwise, we won't be able to see it from our T-Spider. We can also do some DDL operations like adding a column, for example. Here I'm going to add a flow column to this table. With the default value of the famous pi. And it's executed successfully, and now we see, let's see the table's definition. And there you go. And now let's do a select to see if the records have default value. And there it is. So that's it for the demonstration part. What I demonstrated was merely the tip of the iceberg of 10DB cluster and its ability. So we strongly recommend you to try deploying 10DB cluster with Docker Compose like I did, because it's the easiest way for you to understand what it does and whether or not it does the job that you want it to do. So if you're interested, please make sure to check out our official website, 10dbcluster.com, for full tutorials and manuals. And there's one more thing. We're a team that never stops innovating. We sometimes look carefully at our 10DB cluster and wonder, can we make it better? Or can we use it better? Then we will propose lots of what ifs. Like, what if we can deploy a multi-machines cluster that's ready for production with just one command? What if we can scale our cluster at will with just one command? What if we can allocate computing and storage resources that are just about the amount the application demands? What if the cluster can automatically decide which nodes to be deployed on which machines to provide the best performance and reliability? And what if we can achieve fully automatic high availability and let the cluster recover from crash by itself? These are very practical questions and can really boost the efficiency of our production if solved. And at present, there's a wonderful solution to these questions. That is cloud. To put 10DB cluster on cloud, we decided to bring 10DB cluster to Kubernetes using our own 10DB cluster operator. Since our presentation time is limited, I'll just save our time for introducing Kubernetes and assume you know what Kubernetes is and its main components. Basically, our 10DB cluster operator does it all to make sure our cluster works well on Kubernetes. Either it's to create a cluster or scale a cluster. All we need to do is pass a YAML file describing the configuration to one command, and then let the operator does the rest. With modern containers, we are able to precisely allocate resources like CPU cores or disk space to fulfill different clusters' needs. With Kubernetes container orchestration ability, we're able to design rules to make our operator find the best way to deploy nodes. It's also easier for us to automate crash recovery in our cluster with Kubernetes' ability to monitor and manage containers. Advanced resource management, high degree of automation, cutting cluster management costs as much as possible are the main reasons we bring 10DB cluster to Kubernetes. At present, 10DB cluster operator supports basic cluster operations, including deployment, scaling, and also crash recovery. In the near future, we'll put our focus on completing and improving 10DB cluster operator, making 10DB cluster on Kubernetes a reliable solution for production. Again, you're always welcome to join our community and give a try on 10DB cluster. Your opinion and feedbacks are all we're looking for. There are many ways to receive info on our product and contact us. You can visit our official website, 10dbcluster.com, for full documentation, tutorials and guide, and frequently asked questions. Our 10DB cluster is fully open source, so you can visit our GitHub repo to get the source code, try it out, and submit issues and PRs if you find out some problems or improvements that can be made. Also, you can join our QQ group chat to directly talk to our team members, ask any questions, or just to chat if you want. Lastly, thank you all for listening and sticking it through here. I hope I don't bore you out already. It's been a pleasure to present at this event, and I really appreciate MariaDB Corporation for giving us this opportunity. Thank you, and hope to see you soon.
Okay, my name is Xinlong Li. I'm Principal Engineer of Cloud Database from Tencent. Today, I will talk about the evolution of cloud-native database architecture. I will start my sharing from the following three perspectives. The first, background. I will introduce the architecture of the cloud-native database. Some features will also be introduced. Second, practice. I will show what the key technology we use to solve the user pain points in cloud-native database. The third, evolution. I will show what we will do in the future. Okay, the first, background, introduction to the architecture. These slides show the architecture and the feature of the Tencent Cloud Native Database. Tencent Cloud Native Database apart the computing layer and the storage layer. The computing layer writes redo log to storage layer, and the storage layer applies the redo log to data page. When cache miss, the computer layer reads the data page from the storage layer. Master node in computing layer supports the read-write workload, and the slave node only supports the read workload. Tencent Cloud Native Database can automatically expand to 1 petabyte mass storage, and its computing resource varies from at most 96 core of CPU, 768 GB of memory, to at least 1/4 core of CPU, half GB of memory. The read performance reached more than 1 million QPS for each read-only node, and the write performance reached 500,000 QPS. All computer nodes can fail over in seconds and take snapshot and backup in seconds. The serverless means pay less as you need, which means if the demands of data increase, just pay more. If the demand decrease, pay less. The Tencent Cloud Native Database support different ecology, including MariaDB and PostgreSQL. The slave node can expand up to 15 read-only nodes in seconds, and the replication delay from the master to slave is at the millisecond level. Okay, the database architecture of traditional database and cloud-native database are different. The traditional database like PostgreSQL and MariaDB is share-nothing architecture, and the cloud-native database is share storage architecture. The storage of traditional database is inflexible. The different instance in database cluster has their own data storage in traditional database. Each replica added to the cluster requires an independent storage space. For example, if a database cluster store 1 TB data, when replica joins the cluster, it needs 1 TB space on its own machine. One cluster with 1 master and 10 replica needs actually 11 TB storage space just to store 1 TB data. And the storage space in one machine is limited. Therefore, the ability to store data in database cluster in traditional way is also limited. In my view, the storage of cloud-native database is more flexible. No more storage space is needed when replica joins the cluster. Replica can read from the shared storage and space storage, and the shared storage in cloud is much larger than the space in one machine. In cloud-native database, only redo log is sent to storage, which shows slice is TX store, and the storage applies the log to their data page. Replica receive the redo log from the primary node, that is master node, and apply the redo log when the data page is in replica's buffer pool. When the cache meets, both the primary and the replica read the data from the shared storage. Now I will discuss what kind of storage can meet the separation of computing and storage architecture. That is the computable storage. The storage node executes the storage logic of database. When read log is sent to the storage cell, each cell persists the read log and notify the storage client in computer node that the log has been persisted. After the computer node thinks the log has been persisted and the relative data page has been flushed. In background, the storage cell replays the redo log to data page. After that, persist new version of the page. Each page has different version in storage. The main node read the latest version, and the replica may read the old version. The above is the logic structure of storage. The physical structure is introduced below. The data in storage in different storage node has the data in storage in different storage node has its own physical resources. In short, that is separated physical server. Each storage has a storage cell. Each cell has its own redo log space and the page space. Redo log is a fragment according to its page, and each cell has 3 copies. So after introducing the architecture of cloud-native database, everyone has a preliminary impression of it. The following will further introduce some breakthrough technology of cloud-native database. So the first key feature of the cloud-native database is serverless. So what is serverless? Serverless is a mode for user to use the database, I think. User can use the data pay as their need. They just adjust the computing and storage resources of a database dynamically in seconds. Before the serverless, I think the user predict their need like the green line, and buy their resources in database like the red line, and the actually demands is like the green line here. And the serverless can scale like the blue line here, just meet the need of actual demand. The real user scenarios, in real user scenarios, there are a lot of scenarios where useless is used. For example, when developers test their service, the amount of data will grow in a short time, but the database will be idle for a long time. They can adjust their database resources dynamically to save money. And in some service like i2o games or e-commercial, they will explode in a short time. The data will explode in a short time. They need to add database resources to support their service frequently. The compute node of database is stateless, and they can start and stop fast without process like redo log recovery. The storage is perceived expansion and construction. Expansion on demand, automatic construction. The compute node can start and stop extremely fast to adjust the computer resource dynamically. Shared memory is used for buffer pool, which shorten the time, for instance, startup and recovery. and there is no obvious degradation in performance after the startup. Okay. Compute layer offloads the redo log recovery because the redo log is applied by storage layer. The storage layer has different storage cells. Each cells can replay independent, and different cells can replay redo log parallelly. We also do a lot of work about startup and in startup optimization. For example, buffer pool instance initialize in parallel, rollback segment initialize in parallel. As for the shutdown with dirty page flashed offload, as long as the redo log persists, the server will complete the shutdown. And the storage can quickly expand and shrink automatically. For the computing layer, the storage layer is just like can be just abstracted into a storage pool, and the storage pool can dynamically add or delete storage units. The size of storage units is 1 MB. Storage units are scattered on different servers. So if more space is needed, just add more storage units to the storage pool. For the shrink, the space in free extent of each segment can be allocated. Once one free extent is big enough, the storage unit corresponding to the free unit in computing layer will be recycled in background. This provides the true pay-as-you-need ability. In current storage system, with the capacity growing and the I/O delay growing, that principle also applies to the cloud-native database architecture, where computing and storage are separated. Compute node must read the data from the remote cloud storage through the network, which significantly increase I/O delay. For most cloud-native database, buffer pool can only cache a small part of data. Most pages must be read from the remote. Page remote I/O because the bottleneck of the database performance. Secondary cache is created to solve this problem. Buffer pool can eject some pages to the disk of computer node and will read it later. The data in secondary cache is stored on non-volatile storage placed on compute node. Each buffer pool instance has its own secondary cache space, including memory structure and storage file. For memory structure, only a hash table and free list is used to manage the secondary cache. Hash table is to map the page ID from the buffer pool to secondary cache. Free list is used to find out free space in secondary cache. The memory structure of secondary cache is light. The memory only used 1 in 256 amount of data size to manage the whole data in the secondary cache. For example, only 3 MB space in memory can manage 1 GB data in secondary cache. The storage structure is independent and non-segment. Double write is skipped and bypass the file system. PMDK and SPDK is used to write data to non-volatile storage like Optane SSD, BPS, or AEP. As for result, under the configuration of buffer pool and secondary cache 1 to 5, the performance improved 100% in read workload. In addition to performance, the data security is also very important. An important way to ensure the data security is data backup and archiving. For cloud native database, the storage layer can complete data backup and archiving without the help from the computing layer. Even for the computing layer, backup is perception. Each storage cell has a closure of data and log. They can snapshot by their own. One log-based global snapshot process can take a global snapshot without communication between each storage cell. For archiving, each storage cell found full incremental backup data in parallel and apply and replay the logs to the data in parallel. As a result, only a few seconds is needed to back up data, and archiving is to back up data, and when archiving is needed, the archiving speed will keep a GB level. Okay, so far the cloud native database has done a lot of work in the term of storage elasticity and computing elastic expansion and data security will our future exploration direction. Cloud-native database architecture solves the storage expansion problem. The storage of database become very elastic. We can add the replica node, which means just add the computer resources to improve the read performance. However, we cannot improve our writing ability by increasing computing resources. The expansion of writing computing is inflexible, I think. In our future exploration, the exploration of writing computing is our main direction. To solve this problem, log storage is introduced. In the future, a log will be exchanged through the log server instead of directly transferring logs between the master and slaves. At the same time, the data is divided in different data sets. Each data set has only one master node which can write the data to that data set, and the write elastic is expand by adjusting the distribution of the data set. In this architecture, different writing nodes in computing layer shares one global consistent read view. And with log server introduced, the data can be synchronously transferred to different regions, which may be located in other city or maybe other country. User can read the data from local region, which will improve reading performance and availability. Data transferred by main region will be saved independently. If in-resistant disaster occurred in main region, such as earthquake or war, the data could still be available for the user in standby region. This provided very high level of data security. Okay, thank you.
So now it's time for the next slot here at the MariaDB Server Cloud MiniFest. And with me here I have Sudhakar Sanakayala from Microsoft. You're on the board of MariaDB Foundation, right?
Yes.
And we very much appreciate that. So what's your position at Microsoft?
I'm the head of engineering for open source data services in Azure, which is the Microsoft Cloud.
Okay, so that is a very clear description of your responsibility, and it sort of also explains how MariaDB comes in. Or would you like to elaborate on the role of MariaDB for your responsibilities?
Yeah, Kai, my team is responsible for enabling platform as a service for all open source databases. So we support MariaDB and also other open source databases as well. So MariaDB is one of our marquee servers, a lot of customers and developers building interesting applications on top of MariaDB. And they're asking for more capability in the database and also in the service itself. So we are very excited about the growth we are seeing. We're very excited about the interesting applications that customers are building on top of MariaDB, on top of the Microsoft Cloud.
And it's music to my ears because one of the key aspects of what the MariaDB Foundation is about adoption, and adoption on the cloud is great adoption. So you mentioned other open source databases. So how does your usage of MariaDB compare to Postgres and MySQL?
Yeah, Postgres and MySQL and MariaDB, the growth of all these databases has been pretty phenomenal. One of the things that we see is there's some interesting application patterns that are emerging in each of these databases. But we are a relatively new service. We've been generally available for developers for about 3 years now. And all open source databases are growing at a very fast pace. And that shows to tell you that how developers are betting on open source databases and also kind of moving to the cloud as well. So our hypothesis around open source and also the cloud, like cloud native application development, has been proven to be right.
Cool, that's good to hear. So what kind of feedback do you get from your users?
Yeah, it's a good question, Kai. We get a kind of a plethora of feedback, but if I were to kind of summarize in terms of the feedback that we get from MariaDB is one is around database features that developers would like to see, especially around things like parallel query plan, predicate pushdown. Those are some of the common things that I hear. The other next set of capabilities that I hear from developers that they want in MariaDB is around some of the security features, enterprise security features like dynamic data masking and features like that. And finally, it's more on the cloud piece, especially on the Azure side of things. Customers are increasingly asking us to provide Azure Active Directory authentication plugin. They're also asked for data encryption plugin using Azure Key Vault, which is our kind of a key store to hold certificates and other secrets. So those are the kind of the feedback that I hear from customers on things that they'd like to see in MariaDB.
So how do you set up MariaDB for the end users, like versions and upgrades and all of that?
Yeah, so as part of the Azure platform and platform as a service for MariaDB, one of the things that we offer for customers is obviously easy provisioning of MariaDB databases, being able to migrate their data, and also we provide automatic platform upgrades and version upgrades. Right. In fact, one of the things that customers do like about MariaDB is around the longer life cycle for major releases, right? Because customers don't want to upgrade, right? We see this with other databases, right? They want to upgrade to major versions only when they're comfortable and they feel good about the set of features that are coming for these major upgrades. So yeah, I think we provide upgrades for minor and major versions in the platform. And one of the things that we are also that customers ask for is being able to configure when and how they can apply some of these some of these upgrades, whether it's the database upgrade or the operating system upgrades as well.
So one of the characteristics of MariaDB Server, if you compare it to other open source databases, is the storage engines. So they do exist in MySQL, but I believe they are now concentrating on InnoDB mostly, if not only, whereas there are several ones in MariaDB actively. So how does that work for you? Do you have several storage engines, and if so, what's their breakdown?
Yeah. So, Kai, for us, majority of the customers, I don't know, maybe because of, how their current applications are developed, we have majority of the customers running primarily on InnoDB, right? We do get requests from customers to support, MyRocks. Column store is gaining in popularity as well. That's because, interestingly, right, customers increasingly want to run both OLTP and OLAP style workloads on the database. So that's one of the reasons why column store is gaining popularity, where customers don't want to be in the business of building data pipelines and ETL the data, from a traditional, relational database to like a data warehouse style application. So that's why it's gaining in popularity as well. And we do get a few requests for ARIA as well. But predominantly, I would say a huge share of customers, storage engine is InnoDB.
Cool, good to know. And also column store that you highlighted, column store. So those are sort of options when using MariaDB Server, the storage engine. But there's other options as well as in plugins. So, and you mentioned security there. So there are security plugins and authentication plugins and whatnot. So do you offer any plugins as well?
Yeah, we do offer AuthZ plugins, right? Audit plugins essentially,
okay,
as part of the our service. But you're right though. I think the most popular plugin requests that we get are mostly around authentication and security related stuff, and also on authorization and then audit as well, are the three popular plugins requests that we get from customers.
So I was going to ask you, what would you like MariaDB to do? But you already sort of answered that when I asked for what feedback you have from your users. So I won't ask that specific question, but instead going back to an earlier MariaDB Server Minifest, we got actually from Microsoft and others the feedback when we asked the question: is it more important for us to put effort on fixing bugs or on adding new features? The answer we got was that's sort of the wrong question. It's not the only two possibilities. It's very much also about two other things, which are sort of neither bug fixes nor new functionality. And one of them is performance, putting more effort into performance, and the other one is ease of use. So do you have any answer to the question, how could MariaDB Server become easier to use, easier for end users or for you to set up?
Got it. It's a great question, Kai. So, you obviously mentioned, performance. I did point out earlier, like things like, parallel query plan and stuff like that. I keep hearing. On the simplicity piece, right, we do get all the time. And interestingly, we do get more of that because we are supporting a managed service in Azure for MariaDB as well. A few things that come up in my developer and customer conversations, right? One is around, while it's great that there's a lot of flexibility for MariaDB in terms of the storage engine, in terms of the plugins, right? It tends to get, for an average developer who maybe is not a database expert or a database enthusiast, right? One of the common feedback is, hey, can you simplify the choice of the storage engine and the plugins that I should be using, right? And it's an interesting feedback, right? Which is because I love the flexibility, but at the same time, I do get feedback from developers and customers saying that, hey, can you make it simpler? The thing also that I hear is, can we make the configurability of MariaDB a little bit more easier for an average developer? Like, for example, one of the common things that I hear from developers is, hey, look, our workloads are pretty constant. Like, there's a seasonality to these workloads. Like if I have an application, it can be, read heavy or write heavy or something in between, right? How do you help me better configure the various, configuration parameters for MariaDB to suit my workloads, right? So that's interestingly, we hear that. And in Azure, for our open source service, we have something called Azure Advisors. So one of the things that we are working on, and we have some of these where we give recommendations to customers, in terms of the configurations that they can take advantage of for MariaDB, right? So essentially, to summarize, right, customers are asking for more about dynamic and adaptive configuration. And I think, we hear that all the time. So to really answer your question, you're right that we do hear that, hey, make it simpler for developers, right? The flexibility is great, but make us to choose the choices that we make a little bit simpler, right? Is what I hear.
Good, good. And actually, there will be a discussion at the panel later on today about something we call, it's a bit of a pun, it's InnoDB buffer pool politeness. So the InnoDB buffer pool is, of course, a very technical concept, and politeness is a very non-IT term. And that one is about, I think, satisfying exactly what you were asking for, making stuff easier to configure so that the InnoDB buffer pool, which obviously is a part that's hard to configure, that it frees up memory if it's not used, and that it behaves properly if there's too little memory. So stay tuned for that one. And Sudhakar, I would very much like to hear your feedback on that debate then later on after we've had the panel.
Yeah, I'd love to check out that talk for sure. It sounds interesting.
Great. So now I have asked you mostly technical questions, and I will go for a what we could call political questions soon. But before we leave the domain of technical questions, what have I not asked? Is there anything of a technical nature that you wish to add?
Yeah, one thing I would love to add. I mean, we talked about a bunch of technical features. One thing that I did miss out is, you asked about kind of the developers and applications, right? One of the things that we see really a great trend developing, where increasingly customers are choosing MariaDB as the database of choice when they're migrating from Oracle database.
Yes.
That comes increasing. In fact, we have some large customers running mission critical workloads who've recently migrated from Oracle to MariaDB. So that's something that's actually it's of course it's always been there, but increasingly I'm hearing more and more it come up in customer conversations. So that's something that I'm excited about as well, because with the flexibility and configurability that MariaDB has, we feel that we can meet the needs of a plethora of different Oracle workloads on top of MariaDB. And again, there are feature parity challenges and everything. I get all that. But that seems to be a popular destination of choice for Oracle migrations.
Excellent to know, and there we might need your help also in getting the word out that there is this Oracle compatibility mode and that you can run PL/SQL inside MariaDB, which you cannot do in obviously you cannot do it in MySQL. That wouldn't make any sense. They have Oracle for that, and I believe there's nothing really equivalent to it within at least the Postgres that's generally available as an open source product. But we do have that, and we have the core parts because we have users who have migrated all their, like big fintech companies. Our standard example is DBS Bank, and there are videos on that out on the web where they've done that, and we're adding more of that, our Oracle functionality. So your help at Microsoft is very helpful if you can get the word out. And of course, what's missing, we're keen to listen to that. But let that now conclude the technical part, and I'll move to what I described as a political question, and that's of course a bit of a tricky thing. So and it's also meant for the audience to get some interesting insights from you. So when it comes to cloud companies, we and cloud providers, we have a feeling, a sentiment inside MariaDB Foundation that the cloud providers are, of course, good members of the MariaDB ecosystem that increase the adoption, which is what we're about, but that the cloud providers extract considerable commercial value out of the MariaDB server software development. And the conclusion from our standpoint is that should mean that their contribution back to the ecosystem should reflect that. So do you concur with that thinking, or what's your overall feeling on this?
Yeah, absolutely. I do concur with your, with your statement, Kai. In Microsoft, we firmly believe that we want to, further our Microsoft's contribution to open source in general. Like, for example, Microsoft has the most number of, contributions in GitHub to open source than any other company in the world, right? And that's true with, whether it's Linux, Kubernetes, or some of the open source data services as well, right? So yeah, absolutely, we do. In fact, in my team, we have few committers for, other open source databases as well. And we're helping influence and help, the community, open source community for all open source databases. So yeah, absolutely agree. I think that's a fundamental principle on how we operate as well. And I know, I'm very happy to work with your help and the foundation's help to do the, little bit of help that we can do to help the MariaDB community. And hopefully we'll discuss more about that as well.
Sudhakar, that sounds great. So, and just to underline that the type of help that we directly channel in the foundation is of two kinds. One, of course, your contributions to the openness of MariaDB server, meaning your the type of pull requests that we get and which get added to the functionality of the server, and then of course your financial contribution as a sponsor to the foundation. So those would be the types of support that I think come very naturally for cloud providers. And I suppose you would concur, Sudhakar, on that one as well.
Yeah, absolutely. And I think, Kai, as you know, in addition to the being part of the board and perhaps sponsoring some of the MariaDB conference events, right? One of the things that we spoke about is we have a couple of engineers on the team helping with Windows build machines, and also starting to work with the community in some patches, especially around proxy protocol and stuff like that. So expect to see more of that to come from Microsoft in the future.
Excellent, Sudhakar. That's music to my ears. So very happy with your contribution also now for the MariaDB Server Cloud MiniFest. Any concluding words from your side, Sudhakar?
Firstly, I really appreciate the partnership, Kai, with the MariaDB Foundation. Very happy. Microsoft is very happy to be part of that. And of course, we've been working on some, things like, obviously, the getting the word out. But one of the things I would love to do is, share real customer stories with the community as well. Because as I mentioned, we have some really large, customers, well-known, brand names that are betting on MariaDB and running large mission-critical workloads. I'd love to share, I want to partner with the foundation and share more of, how they're implementing their applications on MariaDB, including reference architectures and stuff like that. So I'm very excited about the partnership and looking forward for more.
Well, Sudhakar, thank you. So am I. I'm very much looking forward to more of that as well. It's great to work with you, and thank you for being here at the MariaDB Server Cloud MiniFest.
Thank you. Thank you for inviting me to the MiniFest, and thank you.
Thanks.
Hi, I'm Steve Shaw, open source database lead at Intel, and I'm going to be talking about how the MariaDB Cloud is best powered by Intel. So first of all, let's have a look at some key cloud computing trends and drivers that are shaping the industry today. The most obvious one that we can't ignore is the impact of the pandemic, which, if anything, is accelerating a number of those industry trends towards cloud native that were already present and already starting previously. Just as one example, with many people working from home, and the approach to software development is moving that approach to very similar that has already been taking place in open source development for many, many years previously. Open source software is absolutely key, and this is where web standards and the open source software itself, can prevent that vendor lock-in, giving you that flexibility, and that flexibility to be able to respond to business demand is so key, where you can deploy on-premise, in the cloud, or in a hybrid environment without being locked into one particular model, and give you that flexibility to change very rapidly. We have artificial intelligence as well, which is a key trend. So 85% of businesses have already deployed AI in production. This is only going to accelerate, so we need to have a much more straightforward way to deploy AI in the future, such as deploying artificial intelligence directly within your MariaDB database. And we'll have a look at that further on in the presentation. And finally, with edge computing, we can see that 50% of data is going to be created, and processed outside of the data center or the cloud. So this also means you need flexibility in the database, where you're going to be able to store that data in different formats to be able to respond most rapidly to what the application requires. So this is where a database such as MariaDB with multiple pluggable storage engines is going to give you such a major advantage. So the MariaDB Cloud is powered by Intel. So the vast majority of MariaDB databases out there are already running on Intel-based servers. If you choose Intel, as you can see, you have a choice where you can deploy anywhere within the major clouds right across the globe. So just as an example, MariaDB is already part of the relational database service within AWS and Azure. As one of the most popular databases in the industry, it's already as a standard. But also MariaDB have taken that a step further with SkySQL, where you can actually have your MariaDB database hosted directly by MariaDB themselves, on Google Cloud, but also available on the other major cloud-based environments as well. So what do we actually mean when we say the MariaDB Cloud is powered by Intel? The key thing here is that flexibility. It's the power that you have to be able to respond and build a database that is perfect for your needs. So when we're looking at a cloud-based database environment, where we're really talking, you'll hear the terminology based in terms of vCPUs. So if we take SkySQL running in the Google Cloud as an example, we have these examples of Sky 4X, which is 4 vCPUs, and 8X, 8 vCPUs, all the way up to 64 vCPUs, and then of course a custom level, which is the power tier. What these vCPUs are, this is essentially built on a technology, driven by Intel called hyperthreading or SMT, where we have multiple logical CPUs running on one physical CPU at the same time. This not only gives you additional performance from the actual core itself, but it also has greater levels of power efficiency because we're running multiple vCPUs on the same core at the same time. At the same time, though, also we have very high levels of performance and frequency. So we can see in this example, if you're running SkySQL, you can be running up to 3.9 gigahertz on any individual CPU, on boosting in terms of that all-core turbo. So on one actual physical socket, then all the cores could be running at this level of frequency at the same time. But also we talked about flexibility within the cloud, and this is where the Intel architecture really has a key advantage. So we can see if you want regular compute, say for a transactional database, you can base these on currently available on the 2nd generation Intel Xeon Scalable. But also if you're, for example, running the MariaDB column store and you want large amounts of memory, you can run on a memory optimized based instance as well. It's the Intel based systems and the architecture that is really key to driving this level of flexibility to be able to meet the needs of your MariaDB database. Now, of course, I say this hasn't happened overnight in terms of the processor innovation that drives the levels of performance that you can have in your database today. You know, if we look at over time, you know, going right back in terms of Xeon-based server CPUs, we can see for over 20 years, we've had these levels of innovation that make what you can run today on your MariaDB database possible. So already going out 2 decades, we have 2 sockets and above level of support. We have virtualization is key to running in the cloud, and we have Intel VT technology has been around for a number of years, which accelerates virtualization software. We have encryption, you know, built-in encryption, which is going to be key when you're running in a cloud-based environment, when you're running distributed software across multiple sites. And then we have high performance moving into today, you know, high performance for Ivy Bridge, you know, Haswell-based CPUs, you know, tuned and optimized for running database environments, right through to the present day when we have the 10 nanometer 3rd generation Intel Xeon Scalable processors. You know, we're also known as the Ice Lake based code name. So if we now take a look at sort of beyond the CPU as well, one of the key things for running in the cloud, because you're running where you may be separate from where your applications are accessing where your server is hosted, you need to be sure that both the software and the system and everything is optimized together for a seamless experience. So where the software, the client-based software or applications, they could be running also in the cloud, in a private environment, or as we've seen in a hybrid-based environment. It's this system-level optimization that gives us this almost seamless experience to deliver that performance potential from within the cloud back to the actual application itself. So the key thing here is you have the confidence when running with Intel that we have the Intel-based networking products. So as we mentioned here, the Ethernet, silicon photonics, you know, fabrics. We also have Intel Optane-based technology, which we'll talk about later in regarding persistent memory and SSDs, and also beyond the CPU with FPGAs and GPUs. You know, all of this is optimized to work together to give you that level of high levels of performance. But now moving beyond the hardware, it's not just about having that fully seamless optimized hardware stack. There's also the software advantage that you have of running your MariaDB database on Intel. So as you can see, MariaDB has been available since version 5.1 since 2010 on Linux and Windows x86 64 based platforms. So all those will run natively on an Intel based environment. Anyone with a DBA based background will know how important it is to be running on the mainstream development platform, because that's where development takes place. That's where most people are using the software, and that is where most people are then giving feedback to help and improve the software to be better on that mainstream development platform. Also with MariaDB, as we noted, you know, to be able to respond to edge computing, we have pluggable storage engines. You know, that's going to be key again, that they all have that same experience, have been developed and optimized and available on those key development platforms as well. But then going beyond the database, we have the OS, the hypervisor, the orchestration software, everything. There's a huge stack of software there that needs to be optimized and tuned for your individual platform. And that's exactly what we get for MariaDB running on Intel. And as an example, if we look at the tools supported by SkySQL, we can see all of those tools are available and supported on a Windows 64-bit Intel-based environment. But it's also crucial that your hardware partner or your hardware vendor, is a major contributor and is engaged with open source and is willing to give back to open source. Intel's been engaged with MariaDB since 2011. At the moment, we have Intel engineers dedicating to working on MariaDB software, currently looking at projects such as compiler optimization and scalability. So we engage, and that's how we engage with the open source community to be able to give back and advance that software running on the Intel platforms. Also, we have what I think is a key Intel open source advantage where you can develop at home and then deploy in the cloud on the same architecture. And by developing at home, we mean really on the on-premise environment, but with the pandemic, that also actually means now literally at home. So when you're developing open source software, you can have the knowledge that when you're developing on, say, a Linux laptop or a Windows PC running VirtualBox, that same software can then be deployed exactly as you've developed it directly in the Intel cloud. So what does this mean overall when you're running MariaDB in the cloud? So when you're running on Intel, this gives you that compatibility advantage. So it's key. One of the underlying principles of MariaDB is not to have this vendor lock-in. So no vendor lock-in onto proprietary software or proprietary hardware. A key feature of SkySQL is the ability to make it easy for you to get your data both in and out of the platform. So you can be able to deploy MariaDB, as we've noted before, that key flexibility of running whether on-premise or in the cloud. You can move your MariaDB database seamlessly from one place to another, what we call lift and shift migration. So this is where running on the Intel platform gives you such a significant advantage, because now you're not going to be locked into a particular proprietary architecture within one cloud. You can then move within SkySQL on-premise into different clouds as meets the needs of your business. This is why this flexibility of running on Intel really gives you that advantage for the lift and shift based migration. But if we look ahead as well, one thing that we have now available, within the cloud is the ability to be able to drive higher levels of innovation by leveraging advances within the Intel-based platform. So we mentioned Intel Optane persistent memory earlier. As the chart shows you, really this sits in the tier between where we currently have SSD storage and those. So from NAND SSDs, we also have Optane-based SSDs, and right where you're accessing your data in memory within DRAM. So Intel Optane persistent memory gives you almost the same performance as you're seeing from memory, but it's persistent exactly as you're seeing from disk. So what we're giving you with Optane persistent memory is sub-microsecond levels of I/O. So the most advanced clouds and the most advanced database software are available to take advantage of this new technology. And this is something that's been available within MariaDB 10.5.2, and the Optane persistent memory is available within the SkySQL Power tier by leveraging it from the Google Cloud. And it allows you to have memory map files. So the bin log, currently the bin log and the InnoDB redo log, you can place those on Intel Optane persistent memory. So what advantage does this give you when you're running your MariaDB database on Optane persistent memory? Well, we can see overall, you're going to see significant performance scaling benefits. So within some cloud-based environments, especially if you're running on hard disks with Stripe-based storage, it's not necessarily as predictable, the levels of performance that you're going to be able to get. When you're running on Optane persistent memory, these short code paths essentially eliminate that I/O wait time. And this can be deployed in OLTP, OLAP. Also, the high levels of scalability of PMEM then allows you to be able to run MariaDB column store on large amounts of available memory on systems at a very high levels of cost-based efficiency as well. And some of these examples in tests that have been done, we can see up to 5x of those query-based performance improvements in analytic environments, 2.9x transactions per second. And then as we can see, like 50% reductions in CPU utilization because we're not spending our time in I/O wait time on the storage. So this is certainly going to be a future trend in cloud. And this is where MariaDB is at the forefront, where you can get very high levels of database performance by combining MariaDB within the cloud with Optane persistent memory. At the start, we also mentioned artificial intelligence, and how 85% of businesses have already deployed artificial intelligence in production. As this trend accelerates, as we can see, it needs to be manageable. This is going to become mainstream technology. And this is where a combination of MariaDB and MariaDB enables you to implement machine learning directly in your database. As we've seen from the slides previously, then it's no surprise that when we're deploying both MariaDB and MariaDB, all of these are available Intel compatible in a x86 64 format. So whether you're running on Docker, Windows, Linux, you can get up to speed incredibly quickly by running MariaDB and MariaDB on Intel. But also moving beyond, just the standard deployment as well. Intel, as we noted, the additional systems levels, optimization around allows you to use FPGAs for some of this machine learning based acceleration. And again, this is by running on Intel, you have the opportunity to take advantage of both the optimization at the CPU and the platform level, but also then at the FPGA level. So to wrap up, I hope that you can see the advantage that Intel is passionate about open source. Intel is very much the technology that is powering the cloud, and we look very much forward to partnering with MariaDB in the future so you can have the best experience by running MariaDB on Intel in the cloud. Thank you.
So, welcome to the live part of the MariaDB Server Cloud MiniFest today. We have a panel here, and it's the only live section of our Server Fest, Server MiniFest, and that means it's going to be quite exciting for both the panelists and me. And it's also an opportunity for you to ask questions live. So the purpose of this panel is to be educational, fun, and informative. And this also means that it's more developer-oriented than being specifically marketing-oriented or such, but we do touch on also business and tech issues. So I'm your host, the moderator, I'm the CEO of MariaDB Foundation. My name is Kai Arne, and I will be asking very simple questions, halfway technical, halfway business. And I will now present the other panelists, probably in a bit of a rude order, starting from ourselves at the MariaDB Foundation. First, we have Daniel Black. Hi, Daniel.
Hello. Thank you all for joining.
Daniel is our Chief Innovation Officer from the MariaDB Foundation and calling in from Australia. So this is in the middle of the Canberra night, whereas I have sunshine in Finland here. And he's representing primarily the user base of MariaDB. And Daniel, as you will soon be able to tell, is more technical than myself. Then we have Rob Hedgepeth. He's leading the developer relations team at MariaDB Corporation. And he is based in the US, so for him it's early morning. And he'll primarily be representing SkySQL, and he's the only cloud provider here, so he might have to answer questions also from a general cloud perspective. So hi, Rob.
Hey, Kai. Hey, everyone.
And last but by no means least, we have Steve Shaw, the open source database lead at Intel, very much a deep techie here, very articulate and from the UK, and representing the hardware provider perspective for this, because Intel's customers are cloud service providers. So welcome, Steve. And this also makes me the only non-native speaker, so it's my duty to represent the common lingua franca of IT, bad English. And as this is a live talk for now, you won't even have subtitles, so I will have to do my best. And I will ask questions mostly for everyone to answer, but some are obviously more for Steve, others more for Rob, and others for Daniel. And we will be having 4 sections here: hardware, mostly for Steve, but also for Daniel; software or services for Rob and also Daniel; and then shall we say ethical part about free and open source software for Daniel and everybody else. And then the last section will be about the user perspective of free and open source software, specifically about lock-in. So what do you lock yourself into? Do you lock yourself into software or into clouds or what? So going to the first section here, hardware. Databases were created in a different era where there were hard disks which work different from persistent memory does now. So the design of databases was for a different technology than what we have now, that we have flash memory. And there were different reasons for having caches, and the caches now are much bigger, and the profile of query performance is quite different. So my overall question is, what does this mean for cloud databases, and what does it mean for the users who have to configure them? So what's the end user perspective? And I was thinking now that can we separate this into, shall we say, CPUs and memory and storage, those separately. So perhaps the question should go now to Steve. How do you see this?
Well, I think it's a great question, because I'm on the TPC OSS, so the open source subcommittee, and a key topic in that group is the HTAP workloads. So the hybrid analytic and transactional workloads that previously, I mean, I've been working in databases in fact, running databases on Intel for over 2 decades. When systems, I think if we look, even back then, like just an 8-socket Pentium Pro was more than $1 million. So the capabilities of systems was, very well segmented. I think the hard drives were huge at 2 gigabytes. So, Moore's law very much restricted, the potential that you had with what you could do with a database. So now I think, in the cloud era, if we look now, like 8 vCPUs, compared to that system that cost $1 million, would now cost cents to hire. It gives you that potential to be able to, the hardware capabilities are so much more to be able to run those different workloads. So, and I think now we're in an age where very much the software is almost catching up with the capabilities of the hardware, where people are asking, well, we don't have to run transactions, and analytics, separately now. We can share the data, in the cloud, and we can have multiple sort of hybrid systems. And I think that's the trend, that's the direction that, databases are going in, where people won't be asking, we used to have a separate warehouse from our transactional systems. It will be the case where we just have this pool. And I think that's where the capabilities of features such as persistent memory, already supported in MariaDB, currently for append-only files, but looking at the potential there we have for large terabyte buffers, where we can have our transactional data, different pools, and we can run our queries all over the same data set. So I think that's really very much where MariaDB, with a column store and a transactional storage engines, really fits together and very much blends with the hardware trends that we've been driving.
I guess there's also an aspect of, it's not only just the software being ready just to slot into whatever hardware comes along. There's some re-engineering work as, rotational disks go out, and some, timing assumptions in the underlying code need to get reevaluated as the NUMA architectures actually push the core counts and the virtual CPU counts up, and how to actually ensure there's no contention points on those, because when you've got a really old code base that's around, that sometimes it's some of the simple things that will constantly move as to where the bottleneck actually is. And I guess also on like hardware devices, we're getting contributions in from like ARM and Power to get these features introduced, but we're also actually getting a huge increase in just the volume of data. And as we're getting that, the CPU frequencies are starting to really cap off. So we're really having to focus on like the horizontal scalability to actually meet those demands, not only in column store, but as Siddhartha said, about getting those into parallel queries and other features in the database that are harder to implement.
So Robin, you view on the hardware level from your side.
Yeah, so I think, kind of going off of what Steve and Dan said, I mean, and Steve really mentioned it up front, is this ability to, or, now that we have the capabilities from a hardware perspective to be able to take advantage of both transactional or row-based and, analytical and column-based at the same time is going to be massive. And then Daniel really hit on this idea of horizontal scaling. The capabilities of hardware as they are now, as Steve really, is spoken to now, but obviously in his session before, are really starting to, rather than, kind of trying to, have Moore's law basically be a blocker of some sort, throughout that, we're really starting to open things up. And, coming from an application development, background, that's something that, and Steve had hit on just a little bit before, is, why should I have to, use analytics or large amounts of data separately from my transactional workloads? And anymore, applications, whether it's mobile or IoT some of these things that we may even get into in edge computing, they have higher expectations than ever before. It's not anymore that we'll just stick out a web application that's just simply running CRUD types of operations. We need to see real insights into data, massive amounts of maybe historical or analytical information in real time. And I really think that modern hardware has really helped facilitate that. My layman's view on hardware.
Thanks. Yes, very good. So let's now move to the software part. And I have a couple of questions here, but I'll sort of ask all of them at the same point in time, and then you can give your view on all of them at the same time. And probably this will be giving you, Rob, the word first, and then Daniel, and then Steve. So I'm thinking about the marriage of a database or one database to one cloud provider. And I'm thinking there's advantages to it, sort of hard coding the best characteristics of a database to the best characteristic of that particular cloud provider. So if you do deep integration, isn't that an advantage? That's sort of an advantage point, a good starting point of it. But then there's the other side of it. So, or that would imply that the level of integration cannot be as deep in something like SkySQL, which is a layer between the software and the cloud provider, as I understand it. And you might then also, Rob, have an opinion on whether you view SkySQL as a cloud provider in that sense, or a layer for several clouds. And then looking at the content now of a cloud version of a database, and we now have SkySQL represented here. So what I understand from your presentation and reading up on stuff, so is that SkySQL is sort of the same as MariaDB Enterprise and sort of something more. So it does contain products that are not part of the server, such as max scale for load balancing and other things, and expand for this truly different way of getting right scalability. And as I get it, you could at least have other features that are server specific that exist only in SkySQL, but not in MariaDB Enterprise. So perhaps you have at this point some comments on whether I did understand this SkySQL concept correctly or not, Rob.
Yeah, Kai, and there's a lot to unpack there, right? From this idea of vendor lock-in, kind of preceding now, what would have been software lock-in before, and then talking about how you can take advantage of some of the cloud provider specific functionality. And I think that my thoughts on this are, one, and I spoke to it a little bit inside of my session where, I talked about the architecture of SkySQL. And I think Steve even spoke a little bit of, diving into hardware capabilities and stuff like that. But one of the things that, we set forward to do was to create something that was not necessarily, specific to a particular cloud, and that's by design, where we utilized, the capabilities of Kubernetes. And, for a lot of people out there, they've probably at least heard the word Kubernetes. And, we've been able to utilize some of the, some of the features and some of the advantages of something like an orchestration engine, like Kubernetes, without getting into too many of the details. Some of the things where they key in on, cloud native technology, where, we have the ability to, create, MariaDB as a service, as you had indicated, as something that is a truly cloud native, then utilizing Kubernetes to take advantage of some of the self-healing capabilities, and then be able to combine that with other things that you mentioned, kind of like bringing all the questions and what you asked about before. But as you'd mentioned, MariaDB SkySQL includes things like max scale right off the bat, right? Which is, for those that may not necessarily be aware, it is a database proxy. Like, to put it so simply, we'll do some things from a security aspect. It'll handle things like rewrite splitting, query routing, stuff of that nature, as well as things like HA capabilities. And then combining that with Kubernetes creates this extremely resilient version or form of MariaDB Enterprise Server on the cloud. From a lock-in, standpoint, certainly, there's going to be pros and cons to that. Some of the pros, obviously, is that with being able to use MariaDB currently in GCP or Google Cloud, as well as AWS, and then we're going to be providing Azure soon. We're actively working on that. You have this ability, obviously, to use MariaDB like you'd expect. So either on how you'd use it on premises or use it in the cloud. But some of the things from a cloud provider perspective that's interesting is that they provide a lot of services, right? They may have some analytical or business intelligence applications that you can run from a cloud native perspective that would tie in. And some of the things that makes it really nice having MariaDB inside of these different cloud providers from an enterprise perspective is that we can set up things like virtual private links so that you don't have to leave the cloud in a cloud provider and then come back into MariaDB. You can act as though it's internally communicating with it, and those are things that help from inside of a cloud provider for sure. Was there anything else that I didn't necessarily kind of key in on? I think you had asked about some of the other capabilities like max scale as well as expand, where. Sorry, Guy.
Yeah, I think you answered it, but I think Daniel might also want to expand on some of the things.
I mean, you've obviously deployed to like 2 and I'll say 2.5 cloud providers, and in your talk, you really described Kubernetes as this super standard approach to doing it, and it sort of delivers a lot. But as you, I guess, going between those two, there's obviously subtle differences. So how standard is it once you get down into the lower levels of trying to implement it across 3 different clouds?
Yeah, and I'll try to speak to that, I guess, a little bit. Is obviously I work more on the developer relations side and not directly within the the cloud, or the cloud providers and the SkySQL team. But to your point, and really something that Kai mentioned before in this idea of vendor lock-in is, with cloud provider lock-in, is a lot of these cloud providers provide very similar services, and one of those is Kubernetes services, where utilizing Kubernetes and essentially the Kubernetes API, you can help eliminate work. Now, to your point, Daniel, that's not going to be something that's exactly the same from Azure to AWS to GCP. So there is specific things that that we would have to do as an engineering team to make Kubernetes work and function well within that particular cloud.
That kind of thing.
Exactly. Yeah. And and that's something that we can certainly get in from a cloud native perspective, the ability to tie into block storage and then object storage, those different different options that may exist in the different clouds from a high level are simply just named differently. Of course, as you get deeper and deeper into that, of course, the integrations become a little bit more specific, of course, to the cloud providers themselves.
So I have a specific question, I think, for you, Rob, later, but I'll first ask Steve, what's your take on this?
I think there's many different aspects of sort of lock-in on the software, and on the hardware side. And I've spent a good deal of my career helping customers move away from proprietary systems over to industry standard based systems based on Intel, Linux, and open source software. I think one of the key aspects is, I think, as we saw in my presentation, that ability, to lift and shift. That gives you that peace of mind, on both the hardware and the software side. If you can take your solution and you have that option to lift and shift, between clouds, but even on premise, if you wish, then that's an important checkpoint, if you like, that shows that you're not completely locked into a particular solution. Also, another aspect that I would say, as an open source developer, I'm the author of the HammerDB tool. One thing that I find particularly important as a developer is that ability to, be able to run MariaDB on a laptop. develop my software, on a laptop, exactly the same architecture, and then deploy exactly the same, on premise or into the cloud, test on virtualization. That's what gives us the flexibility, and that ability, I think, overall, to innovate. So, and I think that's the ability that non-proprietary solution, we've moved away from that period of proprietary lock-in. So it's that ability to, I say, just have that flexibility, develop, and then be able to move your solution from one place to another that really is key.
Great, thanks, Steve. And I think that speaks to your term of literally working from home as well. So the question I have for you, Rob, is leading into the area of topic of ethics, where I have a, shall we say, the foundation standpoint. I'm thinking on clouds, but I'll ask an innocent question. So how does, in your mind, the MariaDB being run in the cloud so much affect the development of MariaDB Server itself? And when we in the MariaDB Foundation talk about MariaDB Server, in your language at the corporation, you might call it MariaDB Community Server, but sort of the thing that you get from Docker, from downloads and from the Linux distributions, if you take it off the box. So what does cloud mean for the development in the future, like after 10.6 in your mind?
Yeah, I mean, and kind of putting on my developer hat, one of the things that, kind of, and hopefully I'm, approaching this question correctly, is, from a developer standpoint in the cloud, and Steve really talked about this too, right? Is this ability, you had mentioned it, Kai, and maybe we call it community server, or we'll just call it MariaDB server, and this, how you can develop it on your, and I think every developer would start this way, whether you're using a container or Docker container, or whether you're using a local version, the ability to use MariaDB and MariaDB features, right? And set up the architecture, or the pluggable storage engines in the way that you want to, be able to write that locally. And then the cloud really functions as a way to make that, easier. So kind of from the outside, right? And not determining the, what would be in the server kind of going forward. But from a developer standpoint, I mean, the whole purpose, right, is to provide a service. And it's a little bit different than what, traditionally we've been focusing on at MariaDB, which is developing a product, right? And there's a lot of different, considerations whenever you're developing a product, and you'd kind of mentioned it with the community and, being able to add that in. Now, with the cloud themselves, the service, there's different expectations, right? There's a lot more emphasis on simplicity and usability. So being able to very simply be able to stand something up, have the appropriate amount of configuration, but also have defaults, right? So that I can just 1-2 click my way into a database of some sort that I'm able to use. And then, from a capability standpoint, I mean, we're not currently doing anything different between what would be our enterprise server version and, what's in SkySQL. But again, it's a service that, is deployed out to the cloud, and it could be possible that we could have, different functionality or extended functionality within SkySQL as a service that would possibly make it easier for, as we talk about the emphasis on developers, easier or simpler for them to be able to use certain features. That's something that is certainly possible within, providing a service, as opposed to, as Steve had mentioned, kind of having to set up everything from a product perspective on your machine and, be able to indicate all that stuff. You can just, do that through an interface, or, we're currently working on APIs, deploying APIs so that you don't even have to go to an interface to work with SkySQL. You can just, from a developer operation standpoint, just use an API essentially to do that. And that's something that's a little bit different than if you're working with a product, for sure.
Cool. Yes. So I think this goes back to, in a way, it goes back to the roots of ease of use. I remember a certain ancestor product of MariaDB. There was the 15-minute rule of setting up MySQL back in those days when MySQL was new. I think you're speaking to the very same need. It needs to be very simple to set stuff up, and the defaults need to be good. And the underlying logic is the same in the cloud, but the world the technology is different. So it's a different incarnation of the same thing. So now for the political question. So, and this is asking stuff from a MariaDB Foundation perspective. The MariaDB Foundation is about the adoption of MariaDB and the openness of the development and about the continuity of the product in all possible scenarios of the world. And we think about the cloud in a specific way, which might differ from the way that others are looking at it, like how things should work. So cloud is good. From our perspective, deploying MariaDB in the cloud is deploying MariaDB, so it's adopted more, so it's basically good. However, it differs a bit from like Docker or downloading stuff or getting MariaDB off a Linux distribution, because the cloud providers themselves extract a considerable commercial value out of the software development that goes into MariaDB Server. And here I think the situation is not very symmetric between all the different cloud providers, because you, Rob, represent MariaDB Corporation, who puts in more than the fair share of the development of the open source bits of MariaDB. So our thinking is, and this is not putting percentages or numbers or anything into it, but our thinking at the foundation is that there should be a shall we say, correlation. There should be the contribution back to the ecosystem by a cloud service provider should reflect the fact that the cloud service provider also extracts some considerable economic benefit out of the software. So without going into any more specifics than that, what's your thinking, what's your feeling about this, shall we say, ethical aspect? And I'll give you, Rob, the first word here.
Yeah, and that's something I think that we could have a completely different panel just on this subject matter, at least in my opinion. Obviously, as you kind of hinted, you know, and for those of you that may not necessarily know, what Kai's, you know, describing is, you know, the fact that MariaDB is open source and you can, you know, bring that into, say, a cloud provider and, you know, without using specific examples, be able to provide, you know, MariaDB Server as a managed service in the cloud themselves, and then, you know, contribute what I would consider a nominal amount compared to the millions or hundreds of millions of dollars that they possibly could make off of MariaDB. I agree with you. I fully agree with you. Now, obviously, I come from a fairly different position where, you know, MariaDB Corporation is, I mean, making no bones about it, trying to make money, you know, trying to keep the lights on. And, you know, we obviously, you know, provide quite a bit of contribution into the open source solution. And then with enterprise bits, you know, trying to, you know, create a little bit more hardened or enterprise, you know, ready solution. But we're trying to, you know, be able to essentially, you know, make money off of that. And it makes it difficult with some of these cloud providers that certainly MariaDB is a great product. MariaDB Server or Community Server, as you mentioned before, is a fantastic product. It is, it has a ton of capabilities. You know, it can work for a variety of different workloads. And I think if, you know, we could get, you know, a little bit more contribution, or as you said, more symmetrical contribution from those that are making money off of it in these, I think that only makes sense. I also think that it's not something that people readily think about. I think that, you know, when I talk to, you know, friends of mine, developer friends of mine, and they go and use MariaDB directly from a cloud provider, I think their assumption is that, you know, that MariaDB, you know, Foundation or corporation helps to maintain those. And, you know, they help to provide those within those cloud providers, but which isn't necessarily the case. And I think that a little bit of that is probably just raising awareness to that, not necessarily in such a negative way, but to kind of help, you know, maybe promote this idea, like you had mentioned, of contributing more to MariaDB and, you know, the open source solution, and being able to, you know, especially some of these cloud providers like, you know, Amazon, Azure, GCP, they've got some wicked smart developers that we would love to have, more contributions from them for sure.
Thanks, Rob. So what does this look like, Steve, from your perspective? I expect that Daniel won't say very much different things from what I said, but Steve, what's your take?
Well, yes, as an open source developer, directly as said, so as the author of HammerDB, which is a benchmarking tool, you can use the test MariaDB. One of the origins of that, came from the fact that we had restrictions sometimes in software licensing that meant that aspects such as database performance, just in itself was quite closed. So that's why I decided to write a tool to make it much more open, allowing you to compare and contrast, different platforms. So from my perspective as a developer, I'm fortunate that Intel is a very sort of open source aware employer that allows me, to develop open source at the same time as doing my regular role. But I actually, by coincidence, wrote a blog post directly on how to interact with the project, because I had the feeling a number of people didn't necessarily weren't aware of open source ethics. So a lot of people using cloud environments are new to how to engage with projects. And I think the two key words really are, give back. And that doesn't mean you have to say, well, I can't write the code, so there's nothing I have to give. There's a lot you can give, answering discussions, contributing to issues, ideas, being part of the community. It's really, sharing what you have, giving what you can contribute. You don't have to take on a big portion of the software development. Is just having that ability to give what you're able to give, I think, is the real aspect. As a developer, that's what you feel, that's where you see the value. If it's not going to be monetary value, then you need that form of, contribution, in terms of what you can give back overall to the project to help open source grow and flourish.
Great, thank you, Steve.
Also, I guess a huge big role in that into instilling organizational culture is like, this isn't throwing away money. This isn't throwing away people's time. This is making an investment in how everyone sees it, and not just as, oh yeah, we'll throw out an open source badge and say we're open source. It's got to actually be backed up by substantial behaviors around it, to actually start the process of being a contributor, being able to go out and help Stack Overflow, being able to saying even just our customers and users are wanting this sort of feature. There probably needs to be a bit of mentoring in the culture side too, to make it.
And that's part of why we have MariaDB Server Minifest like this to foster that culture. So we'll conclude this panel by a forward-looking technological question, and that's about edge computing. And I'm not really sure about what edge computing is, and I'd like you to educate me about what it is and educate the viewer. So I have a question. Is edge computing the opposite of cloud computing, or is it a special case of it? I like to put matters in a very simple form. The cloud is a modern word for a data center. It has evolved from something that already existed in the 70s and of course in its modern form. Whereas I believe that edge computing has evolved from something that started only with the internet, with mirrors that developed into CDNs, content distribution networks. And then you have the opportunity of having part of the data in the form of MariaDB database or something else distributed in many places. And now in particular, I read about what happened this week, earlier this week, with lots of outages in the internet, not related to databases, but big services starting from Amazon and Guardian and the UK government and stuff, based on CDNs not working. So here I'd like to understand some basics. So what's the relationship? What is edge computing and how does it relate to the cloud? And perhaps I think Steve is the right guy to answer at least first.
Well, I think it almost goes full circle back to my the first answer around Moore's law, and the cost of computing. When I mentioned a couple of decades back, you were looking at $1 million plus for what would now be a very modest amount of compute capability. We now have instead a huge amount of compute capability at lower costs that can be deployed right throughout the network. So I work directly with telcos who are big users. That's the best example I can think of of edge computing. Big uses of open source databases to gather and process data external from that central cloud or data center, essentially at the edge. And it's really, I would say it's in many ways, it's the same answer. It's Moore's law that drives, the capabilities you have to be able to gather and process that data for faster response times, higher levels of availability. That's really what the advantage of edge computing gives you. But as also from that perspective of data centers, in the 1970s, it's still very much a similar approach, in terms of software, whether it's in the cloud or whether it's at the edge, we're still using the same hardware architectures, we're still using the same software. We're using MariaDB on Intel, we're just applying it at different areas, aspects, or parts of the network.
Good, thanks. So Daniel, some concluding words now on like all of the topics we've said
on the edge computing. On the edge, it's really fascinating to see it going out, and I guess MariaDB, even with its MySQL origins, sort of has had like the replication aspect for ages, and the units growing with the synchronous, the multi-source, and while the edge computing is like pushing about unique aspects, the concurrency of databases makes some of those aspects a little bit challenging. But on a read-only, provided you've got a bit of latency, pushing data out is making a better user experience, which is what keeps us going all the time, from all the innovations across all our speakers that show that the MariaDB is a good foundation for breaking apart and doing innovative things in clouds and stripping back layers and adapting them to various storage. So we're really, I think, very fortunate to be in such a lucky position as an open source project.
Thanks, Daniel. And Rob, you don't have to say anything on edge if you don't wish to. Some concluding words on MariaDB and cloud from your side.
Yeah, kind of going off of what Steve and Daniel have kind of set up. I think that the ability, one, obviously for those that may not necessarily have much of an idea of edge computing, and what Steve spoke to a little bit, it's a way to solve a couple of problems, right? Where essentially, and then it kind of flowed directly into what Daniel said, which is this, kind of heightened expectation. We have more and more types of devices, types of applications, types of solutions that are ultimately utilizing MariaDB, and edge computing will, essentially, for the simplest explanation, make that faster and make that more responsive. But one thing that I will say from a concluding aspect is that as we've talked about, various things like, being able to, put a MariaDB in the cloud or be able to use it from a container approach. And, even as we get into the different workloads that it can handle through different storage engines, I think, my main takeaway is that MariaDB is constantly innovating. We have, an awesome community out there helping contribute to this. And for those of, outside of, maybe even listening to this Minifest that may not necessarily understand, relational databases are not old and crusty. There are lots of innovations happening And it's not just the stake of, say, maybe a NoSQL or, those who shall not be named, from years ago. MariaDB is constantly innovating, and it's in thanks to, thank you to the community out there. It's eye-opening to me. Just every day I go into work, or I'll go out to different projects, and just the resourcefulness and the ingenuity of our community is certainly breaking down this thought barrier of old and crusty. It's certainly the opposite of that. It's very exciting, and thank you very much, Kai, for having me on here. This is with Steve and Daniel. It's been awesome.
Great. So those who shall not be named, that was a good expression. We'll start using it, but I will instead name you, the three of you, Steve, Rob, and Daniel, and thank you very, very much for making it to this, making this panel quite an interesting one. And I'm looking forward to having more panels with you. We will take a break over the summer in the Northern Hemisphere here, and continue with other server fests when autumn comes. So thank you also to everybody who's listened in, and all the other presenters at this MariaDB Server Cloud MiniFest. But especially thanks, Steve, thanks, Rob, and thanks, Daniel.
Welcome.
Thanks, Kai. Thanks, everyone.
Thank you.